I think we all have like Marone's words echoing in our heads, sometimes for better or worse. If you ever come to him and say, I've got this new idea or I know this new thing, Todd, what we say? I don't care about the new thing. Tell me about the old thing. I know that works. So our next speaker, Maxime from MIT, is going to tell us about his tape robots, which may not be the new thing, but they do work, and we still need them. So let's hear about the new old thing.
Thank you. So first, let me start with the motivation why we decided to take on that project and why we think it's interesting even to come here and talk about it. The matter of fact is that our experiment writes approximately order of magnitude 100 petabytes of data every year that need to be stored on tape. And the estimates is that in 5 years, this amount will go up by the order of magnitude. So smooth tape operations are critical for our experiment. But when it comes to sites that have tape capability, there are only few of them, and only one is located here in the United States. It's at Fermilab. And, vulnerabilities to tape sites become really critical because like natural disaster can happen. And if they think this is just a theory, they did happen to some of our sites. Fire, typhoon, and massive rain did happen already in the past. So if we look at sites at CMS that have tape capability, you see on top, it's basically one biggest one is located at CERN in Europe. Fermilab is the second biggest one with 240 petabytes. And the rest of the sites you can see they are all located in Europe and they have smaller capability. So to me, for example, Fermilab site is a critical point of failure in our experiment because God forbid something happens to it, our experiment will be in deep trouble. So when we learned that Harvard actually purchased a tape robot and started to operate it, and they came to us and basically asked us if we wanted to buy in, and by buy in it meant like purchase tape cartridge. And the tape robot looks very similar, if not identical, to what Fermilab has. Of course, we decided to jump onto that opportunity. And when it comes to tape storage, of course, there are pluses and minuses. Pluses, of course, it's resilient storage and it's cheap. For example, our site at the moment provides 16 petabytes of raw disk storage, and it was accumulated over a decade. Every year we kept buying disks every year. And here we bought 15 petabytes just like this, basically, with no effort at all. Minuses, of course, it's operational cost, but it's handled by Harvard Group. We don't even worry about it. And of course, reading is slow, but well, it is what it is. You have to have some minuses, right? But the question then became, can we actually use this tape for CMS operations? And the major difference between our setup and the rest of the CMS, and that was, well, for that matter, is that we don't have full access to tape libraries. And I try to explain it here on this plot. So for example, on the bottom side, you see a tape robot with a POSIX disk buffer in front of it, but it's owned by Harvard. And there are a lot of groups from Harvard that use it. We are just one of the users. And we don't even see this file system because it's exposed to us through NFS mount point. And this setup is actually puts a lot of restrictions on what we can physically do with tape when it comes to day-to-day operations. First of all, of course, we have no access to tape libraries. So for example, if somebody needs to stage file from tape to disk, we physically cannot do it. It's not available to us. And because it's NFS, it poses another restriction. The NFS doesn't have extended file attributes. So for example, checksum this is a number that people use to check if the transfer was indeed okay, is not available naturally to us. So, but CMS uses all these features naturally when it comes to other tape sites. So what do we do in that situation? After staring at the problem for some time, it dawned on us that in principle, we can separate all incoming tape calls into two different categories: file status calls and data transfer calls. And after staring at it for some other time and talking to some people at Fermilab, let's be honest, we finally figured out what we really needed to do. So our solution is on the bottom. So we decided, since there are two different categories of calls coming to us, let Apache server handle it and split them into two different flows. One is basically data transfer calls. It will forward just to XRD servers. And file status calls will be handled by custom CGI. And custom CGI, people use a tape REST API. Basically, it's by interface when it comes to talking to tapes, admitted by all LHC experiments. And basically, well, I implemented it myself in a couple of weeks. Yeah, and it all started to work at a certain point. And let me describe, for example, how we handle one of the most important stage out calls. So when file transfer system figures out that the file is not available on disk buffer and it needs to be brought from tape for reading, then it issues a call that comes to our Apache server saying, well, we need this file on disk so that we want to read it. It's our Apache server then invokes a CGI call. This is all, of course, our part. And then with Harvard, we agreed on very simplistic setup, how we can communicate that we need this file on disk. So we basically literally tell Harvard guys, we need this file on disk. And Harvard team actually makes it happen. So it happens behind the scenes, but it works. So once we figured out that, okay, it started to work, the setup seems to be okay, the question became, of course, how well does it function? And here are a couple of plots, basically, that shows you data flow into our tape system. You can see that data flow never stops. This is a typical week. On the bottom left, you can see that every week, approximately 250 terabytes come in, like 60, well, close to 70,000 files. Right now, if we look at how much data written on tape, it's around 6 petabytes. And it basically floats around that amount, meaning that every week there are 250 terabytes of deletions keep happening. So we keep using this tape. At the moment, the limit, our network is throttled so that we have a limit of 7 gigabits per second. That's our network available. However, university promised that we will have 100 gigabits available by the end of the summer. Reading from tapes right now by CMS doesn't happen as often. You can see it doesn't happen. Then there is a spike, and then nothing happens again. Once 100 gigabit becomes available to us, of course, we are going to push this one to see how much simultaneous writes and reads we can do, we can sustain over long period of time. Yep. And of course, I forgot to mention in the beginning of the talk that, tomorrow we are not the only ones trying to make this particular setup work. There is a University of Amherst that bought into the same Harvard tape robot. And tomorrow in a joint Atlas CMS session, both teams will have more detailed talks with more things to show. Yeah, and if you are interested in more, please come to that talk tomorrow. And that brings me to the end of my talk. So the bottom line is that we bought into the tape robot that we don't own, and that posed for security reasons a lot of restrictions to us. But we managed to make it work under the CMS umbrella. So we believe that, and I hope that If any other group finds themselves in the same situation, they will be able to benefit from our experience. I believe any group that uses underneath XRD or Globus protocols, this will work out of the door. So we have it all in the repository, yeah, and people can check it out. And if even if it doesn't help, I am pretty certain I will be able to make it to work in a couple of days. And that's it for me.
Thank you. Do we have any questions for Maxim? Here.
Hey, Stefan Pipero from Purdue. Nice talk. Thank you, Max. I was just curious. In principle, the CERN tape archive, which handles similar tasks at CERN, as you pointed out, they claim coexistence with other tape systems, tape robots. I was curious if you consider the possibility of having a CDA running on this tape system at Harvard in parallel with their existing IBM system.
All right, now we are going to slide into jargons, but CTA underneath means access to tape libraries. We don't have access, period. We cannot use any CTA of certain setups. It's not gonna work.
I know our friends from LIGO also operate a tape robot. Have you talked to them at all? And
LIGO?
Yeah.
Group from MIT?
no, LIGO. Well, I think it's actually at Caltech.
At Caltech?
But I know they operate a tape robot, but that's the extent of my knowledge. And I don't know if
We
anyone.
have some people from Caltech that I know. I will talk to them after the meeting because I know I was not aware of about. Well, and of course the question becomes again: did LIGO own it and have had the full control of it or not? I mean, that's.
I believe they do, but I can't speak authoritatively. Do you have any more questions? If not, let's give Maxim a final round of applause.